did the background on these confidence intervals, and we wrote down our formulas, or well, not wrote down because I printed notes for you. We have our formulas for finding them. So we need to do an example of that today. So this one, I think it was the same thing we started out with on example 1. We found the p-hat in the scenario, so it's the same problem. But I'm asking you to find a 90% confidence interval for the proportion. So our p-hat, just like we were doing before, x over n, 1,123 over 1783. And what did that turn out to be? 0.6298, is that what we had yesterday? Okay. So then we need to do a couple things. If we look at our formula for these confidence intervals, we have to have the p-hat, our proportion. Then we need a z alpha over 2, and we need an n. Those are the only 3 numbers we have to have. What is my n in this problem? Then my z alpha over 2. Okay, so let's talk about this. Z alpha gives you area to the right, okay? If I'm talking about a 90% confidence interval, I want 90% to fall between these values, all right? So that means how much is left for the ends? Right, you have 10% total, so 5% on each end. So this is like a z for 0.05, because I would have 5% to the right. Does that make sense? We have 90% in the middle, 5% on each end. So the area to the right is 5%. When we look that up in the table, we've done these, but it's been a little bit. You are looking, the table gives you area to the left. So if I have 5% to the right, what percent do I have to the left? 95. That is your area. So that's the probability inside the table. So you are trying to find 0.95 inside the table. Okay, and then we need the z that matches that. So when I find 0.95, I have a 0.9495 and a 0.9505. Do you guys see that in your table? So it would be right in between them. So that's 1.64 and 1.65. So I'm going to call it 1.645. Does everyone know how I got that number? Okay. I want you to look at something. On the bottom of your table, this normal table, it has confidence interval critical values. And the first one, 90%, and it tells us z alpha over 2 is 1.645. Now, these are the common ones, 90, 95, 98, 99. Is that every possibility? No. So for these common ones, you could just look down here. But I wanted to show you how we got it, because I could ask you to make an 80% confidence interval. And that number is not given, so you have to find it inside the table. Okay. So now I have all my information. We do need to verify the criteria since we're talking about p-hat. I tried to put some blank slides in your presentation or in your notes packet as well, so if you need extra room. So the criteria for p-hat, there's 2 of them. We had to know them for our quiz yesterday. What's the first one?
N times p times 1 minus p is greater than or equal.
So n times p. Oops. Times 1 minus p. And remember, on the criteria, you don't necessarily have to show me a lot. I just need to see enough to know that you're checking it. So if you multiply those, you get 415.7, so that's definitely bigger than 10. We're talking about all registered voters, so would 1,783 be less than 5% of the population? Yeah. So those are my criteria. So now we've checked everything, we've checked our criteria so we can do it, we have all of our values, so then we just plug them into our confidence interval. So the lower one is p hat minus z alpha over 2 times the square root of p times 1 minus p over n. Remember on your formula sheet it does have them both together. The only difference with the upper one is what? The add. So what I would do is type it in my calculator once and hit second enter, change my minus to a plus and get the other one. So 3 to 4 decimal places is fine here. Did you guys get those answers? You're double checking me, right? Make sure I'm not putting anything in my calculator wrong. So I have it written as a lower and an upper. The actual confidence interval would look like this. So what does that mean? It was a 90% confidence interval, so we are 90% confident the proportion is between 0.611 and 0.649. In this particular scenario, it was talking about registered voters who were in favor of the death penalty for someone convicted of murder. So based on this, would you think the majority were in favor of it? Yeah, we're 90% confident it's between 61 and 64.9%. So we're fairly confident that it would be in that value. Now, does that mean it has to be? No, we're 90% confident. There's a 10% chance that it's outside this window. Okay, so we have now found a range of values and a measure of how confident we are. Any questions there? So the next example, I've given you a lot more information here. So a Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Gallup reported the following survey methodology. Results are based on telephone interviews with a random sample of 1,016. What's that going to be? That's our N. National adults aged 18 or older. For results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. I want to know, can you tell me what the confidence interval would be here? They reported 54.9%, right? And they said their margin of error is 4%. Remember yesterday we wrote down the margin of error is that whole z alpha over 2 square root of p hat 1 minus p hat over n. The margin of error is this whole thing that you add or subtract. So they already calculated that for us. So So to find the lower number, what would you have to do? Subtract. If we did 0.549 minus 4 percentage points, so minus 0.04, we get 0.509. To get the upper one, you would take their value they reported plus the error, and that's 0.589. So that means this was a 95% confidence. So 95% confident the proportion who believe the tax is fair is between these values. Questions on that? So that was really just interpreting. I want to do a couple more where we actually create the whole interval and make sure we're okay with that piece. So a survey asked 800 16 to 17-year-olds in the U.S. if they've ever used their cell phone to text while driving. Of these, 272 indicated they have. Obtain a 95% confidence interval. So for a confidence interval, we have to have a p hat, an n, and a z alpha over 2. How do I get my p hat? X over n. So 272 over 800. My n was just the 800. Z alpha over 2, we could figure it out. If 95% in the middle, that means there's 5% for the two ends. So that's 2.5 on each end. So if this piece was 0.025, what would you have to look up in your table? You'd have to find the area when the area is 0.975. Or if we look, 95% confidence is one of those common ones. So if you look down at the bottom, 95%, the Z alpha over 2 is 1.96. So you can get it either way. We should verify the criteria to make sure this works. Again, you don't necessarily have to show a lot, just enough that I know that you checked it. So n times p times 1 minus p so that's definitely bigger than 10. Would 800 be less than 5% of all 16 to 17-year-olds? So now we can actually do the confidence interval. So the formula is p hat, so 0.34. Can I just write it together, write the plus and the minus, and we'll just know we have to plug both of them in the calculator. Z alpha over 2, 1.96, times the square root of p hat, 1 minus p hat, over n. So I'm going to do the minus one first, because that will give me the smaller number. So I get 0.307 and 0.373. So I'd be 95% confident the proportion of teenagers who have texted while driving is between 0.307 and 0.373.
Will we always like have to write a sentence with it, or
Only if I say interpret.
Okay.
What would happen if I changed my confidence level? What's going to change in this whole setup? Well, the only formula, if I'm changing the alpha, it will change this z alpha over 2, right? It'll be the same scenario. I wanted to show you, we can also do confidence intervals on our calculator. So I wanted to do the same example, but I'm going to change it to a 99% confidence interval, and I'm going to do this one on the calculator to show you how. So if you would, on your calculator, you need to go to Stat, Tests, and if you scroll down, we want letter A. It's called a 1 proportion z interval. Okay, we have 1 p hat, we're using a z value, we're getting an interval. So it's called the 1 proportion z interval. So you just have to scroll down until it gets there. Okay, when it comes up, it's going to ask you x in sea level. So my x in this case was what? Just like when we calculated our p hat, 272. My n, my total population, was 800. My confidence level, I want 99% this time, so 0.99. And then if you hit enter, we get this. Did everybody get their confidence interval? Anyone have trouble finding that on the calculator when you need to look at something? How does this interval compare to the first one? So the first one we had started at 0.307 and went to 0.373. This one started at 0.297, so that's a little before this, and ended at 0.383. So what happened to it? It got wider, right? And that's going to happen. If I want to ensure 99% of the values are between it, I'm going to have to stretch them out a little bit. You know, if I only need 80%, I can make it a pretty narrow range. But the higher my confidence level, the wider that interval is going to be. Another way to think about that is the error increased. You know, the error is how far you go from your p hat. We went further from the center, so we had more error on this one. I made a little change on my notes after I printed yours, and I have added in a question, but I think you have a blank slide after this, so you can put it on there. So this is going to be, there's some on the homework like this, so if you don't want to write down everything, we need to find a point estimate. So we have to find a point estimate is p hat, the margin of error, that's e, and the number of individuals in the sample, so that's n. So I have given you, sorry, not the number of samples, the number of individuals in the sample with the characteristic x, sorry. So we have to find p hat, e, and x for this scenario. So in this, we know that when we build a confidence interval, it's centered around your proportion. And if you take your proportion and subtract your error, you get the lower bound. If you take your proportion and you add the error to it, you get the upper bound. So p hat should be the middle of these two things. How do you find the middle? Yeah, it's like the mean. Add them up, divide by 2. Okay, I need to find the middle. For the average. So I have my p hat 0.0625. The error is how far from the center you go. There's a couple different ways you could get it. Can you give me an option? Yeah, we now know this middle. We know these values, so you can just subtract. So I could just take like my upper minus my p hat. Or you could do your p hat and subtract off the lower, either way. And we get an error of 0.0115. The final thing I want is x. Remember, p hat is x over n. We found p hat. I don't know x, and n was given in the problem. So if we multiply that over, x is 70. So we could work backwards from that confidence interval to get some information. Any questions so far? Are you guys okay if I go ahead and finish the last thing? It's pretty quick. It's just talking about how big a sample needs to be. So sometimes we have to decide, like if we are going to conduct an experiment, we need to know how many individuals should I ask. And so this is answering that question. How big should your sample be? It's just using formulas. So you don't really, I could show you how the formula is derived, but it's really not necessary. In this case, you have a formula sheet. It is on there. So chapter 9, it's got sample size in the second column and this first bullet. We have two different scenarios. This first scenario is assuming that we have some prior data. So we might have a proportion from a previous study or something, in which case we would use that. The second one is what we would do if there is no prior data to go off of. And that is all stated in your formula sheet too. The first one you use if there's a p-hat. If there is no p-hat, we use the second one. So we'll just look at an example of that and then we're done. A sociologist wants to determine the percentage of residents of America that speak only English at home. What sample size should be obtained? So we're trying to find N. If she wishes her estimate to be within 3 percentage points, so that is my error, 3 percentage points, so the error would be 0.03. 90% confidence. What is that confidence level helping me find? The confidence is what tells us what our Z should be. So Z alpha over 2, if it's 90% confidence, what do we use? So it is given in the table at the bottom. What's the Z for 90%? Assuming she uses an estimate from the census in 2000 that had 82.4%. So she is going to use this p-hat, 0.824. And then we have to figure out how many people she needs in her study today. So we just use the formula. Since we have a p-hat, we're using the first one. So N is p-hat, so 0.824. 1 minus p-hat, so 1 minus 0.824, times Z alpha over 2, 1.645, divided by the error, you're looking at 3%, so 0.03 squared. So we put that in the calculator. Okay, did you guys get 436.04? So would 436 people be enough? No, even though this rounds to 436, you always have to round up in this scenario. So 436 people wouldn't be enough, we need just over that. So she has to ask